Hello and welcome to this tech tip. Today we wanted to show you how to quickly detect and find outliers in your data in IBM SPSS statistics. My name is Astrid Cook and I'm an analyst here at version 1. So to get started, make sure you open up IBM SPSS statistics and bring your data in. Then you'll go to the Analyze menu, go to Descriptive Statistics, and go to the Explore procedure. This will open up the Explore dialog box. Now, you can choose your variable or variables that you want to include in the dependent list. Here, I'm examining a variable called TV hours, and this is just the number of TV hours that respondents watch in a day. You can select Statistics and Plots for the Explore procedure. If I click on Statistics, I can ask for a table of outliers. If I click on Plots, I could ask for a stem and leaf plot or a histogram. I can also ask for normality plots with test if I need that as well. So once you've run the Explore procedure, you can start by examining the descriptives table here. So I will be able to see the average and the 5% trim mean. Now the 5% trim mean sorts the data and it removes the lowest and the highest 5% of values and then averages the remaining values. So you can compare the mean to the 5% trim mean. Also, you can look at the data distribution and minimum and maximum values. Now, I did ask for outliers. You see the table of extreme values. SPSS will show me the highest and the lowest values. So the top 5 highest and the 5 lowest values. And we can also use the box plot. Now, here in the box plot, the blue box is where the middle 50% of cases fall. Dark line is the median. If it's a circle, it's an outlier. If it's a star, it's an extreme case. So when you examine the box plot, you can see outliers and extreme cases visually. So just so you're aware, you can flag outliers in your data as well. We wouldn't remove them from the data, but at least you know where they are. And you can use a procedure called data validation. So this is on the data menu. But this will allow you to identify the number of rule violation and flag cases that violate the rule. Now, if I look at hours per day watching TV, I could set a rule that say if the hours per day watching TV is greater than 7, then just flag the case in the data. And it will do that for me. And it will also let me know how many cases violate that rule. So 96 cases have values greater than 7. Now for data validation, just so you're aware, we've done a separate webinar on this topic. So you can go on our website and click on data validation to learn more about it. So here are some tips and best practices. First of all, you can visualize your data to spot outliers. We did that with the box plot. Make sure that you understand the effect that outliers can have on your analysis. That's critical because they can have a significant impact on any analysis. You want to make sure that you verify outliers using methods like box plot, explore, and also data validation. Remember, data validation allows you to flag cases in SPSS. It doesn't remove the case, but it flags it up based on a rule that you create. So you can identify outliers and you could use data validation to flag them up in the data set. You want to make sure that you document and explain your approach to handling outliers as well. Now, an outlier is a data point far outside the normal range. It could be valid, just extreme, or it could be erroneous. I also wanted to mention an anomalous case or anomalous cases. So this is any data point that deviates from expected patterns, and this includes outliers and errors. We do have anomaly analysis in SPSS as well. And what this will do is allow you to put a number of fields in and find cases that are anomalous across a number of fields. So we'll do a future video on anomaly analysis. But overall, detecting outliers is critical and data understanding and examination is crucial. Because outliers can have such an impact on the results, you want to make sure that you spot them early before you encounter problems later on. So I'm in IBM SPSS statistics, and to get started, I want to go to the Analyze menu, and I'll come down to Descriptive Statistics, and I'll select Explore. This brings up the Explore dialog box. This is exploratory data analysis. Now I'll take TV hours and move it into the dependent list. So you can see TV hours is here. I'll click on Statistics, ask for Outliers, click on Plots. I can ask for a stem and leaf, or a histogram, or both, and I'll ask for normality plots with tests. And then I'll click OK. So we've got the case processing summary here. We can see the number of cases. We can see the number of missing on this variable. We can compare the mean, 2.86, to the 5% trim mean, 2.64. So there isn't a huge difference, but remember the 5% trim mean takes off the top 5% and the bottom 5%, and then the remaining cases that will take that average. So we'd be interested in the difference between the mean and the 5% trim mean. We can also see the minimum value here, 0. So there are people who say they don't watch any TV. We have 21 hours. Now there is someone, or there are people who are saying we watch 21 hours of TV per day. The question is that real? Is it possible that someone could watch that much TV per day? If we come down and look at the extreme values, so these are the outliers that I asked for, and we look at the top 5, we see that there's one person who watches 21 hours, and then we have 4 more people who watch 20 hours. So we do have people who are recording huge values for TV watching. We also have those who say 0, so people who say they don't watch any TV in the day. And it lets me know that this is only a partial list of cases with a value of 0. We have the test of normality. And also, if you look at the histogram, you will see that most people don't watch very much TV, but we do have people that are watching a lot of TV. So we have people who are watching more than 10 hours. If we look at the stem and leaf, again, we can see extreme values. And then if we come down and we look at the box plot, we were saying that the middle 50% of cases is represented by the blue box. But you do see a number of outliers and a number of extreme cases. And you can also see the case numbers on here as well. So the Explore procedure is a great way to examine your data in depth and will help you identify outliers. So that's everything we wanted to show you today. If you want more information, you can visit us at www.spssanalyticspartner.com. So thanks for watching, and bye for now.